So we are going to talk about acids at the beginning. So this chapter is on acids and bases. We're going to start with acids. I imagine that most of us have heard of the word acid in different situations. Maybe you've heard the term acid rain, acid indigestion. It turns out that acids are very important in biology. If you've taken introductory biology at Goodwin, you probably have been introduced to the terms DNA and RNA. And if you remember what DNA and RNA mean, the A in both cases stand for acid. So this is deoxyribonucleic acid, this is ribonucleic acid, but DNA, which is basically your genetic material and my genetic material, is a type of acid. RNA, which is related to DNA, is also an acid. It turns out if you studied cellular respiration, again, you may or may not have talked about this, but acids are actually very important in cellular respiration as well. So even though you may have heard the word acid in different contexts, you might have heard acid rain or any of these other things, acid is actually a very formal chemical word. And there are different chemical definitions for acid. I'm going to show you one or two of them today. And so let's start. An acid this is one definition of an acid. It's not the only one, but this is one that we're going to use a fair amount. Acid is a material, any material that releases H plus ions when it's dissolved in water. So this is a hydrogen atom with a charge of +1. It's not a neutrally charged hydrogen atom. It's a hydrogen ion with a charge of +1. So that's our first definition of an acid. Material that releases H plus ions when it's dissolved in water. And as I mentioned, there are other definitions of acids, but this one gets used a lot in biology and medicine. So we're going to use it predominantly in this class. Here's an example. This material over here, HCl, is hydrochloric acid. If you take hydrochloric acid, that's a gas. Don't worry about the G here. That's not super important. But I have highlighted this hydrogen atom in red. If you mix this material with water, what will happen is that the H and the Cl will disconnect from each other, and you will form H+, you will form Cl-, and you'll still have water running around in your liquid. So because this material over here, HCl, can, when you mix it with water, disconnect. The atoms can disconnect and form H+ and Cl-. This material here meets our definition of an acid up here. Our definition was a material that releases H+ when it's dissolved in water, and look at this. This stuff releases H+ when it's mixed with water. So, and because of that, this stuff is called hydrochloric acid. But even if it was called something else, you could see by this chemical equation that this stuff over here does release H+, and so it is an acid, no matter what you called it. So, what I want, there is a little bit of memorization that comes with this unit. Maybe you would disagree and think that it's a lot, but at least here's one of the things that I just want you to memorize outright. The HCl is the formula for hydrochloric acid. I want you to memorize that particular acid because it does show up a fair amount in biology, in medicine, and in this course. So HCl is hydrochloric acid. There's another way of thinking about acids, however. I just told you that an acid is something that releases H+ ions when it's dissolved in water. And here's the reaction again. HCl plus H2O releases H+, Cl-, and water. But what is H+? There's another way of thinking about what an H+ ion is. At the beginning of the course, I was showing you pictures like this, cartoons like this, and I said this is a hydrogen atom. Why is it a hydrogen atom? Well, it has one proton, and every atom that has only one proton is hydrogen. And it also has an electron, so one proton which is positively charged, one electron which is negatively charged. So in this case, this cartoon version of hydrogen that I'm drawing here does not have an electrical charge. It is not H+. This is just H. without the positive charge. It's neutrally charged hydrogen. So if I wanted to make this thing down here, if I wanted to turn this into H+, what would I have to do? You can pause the video and think about that question, and I'll show you on the next click. So here I'm going to show you, if you wanted to turn a neutral hydrogen atom into a positively charged one, you have to get rid of the negative charge. You have to get rid of the electron. And if you get rid of the electron, then you turn your hydrogen atom into an H+ ion. So this thing over here is H+. So this cartoon version of H+ is really just this thing over here. It's H+ in the equation. However, this is, if you look at this in its barest form, H+ is pretty much just a proton and nothing else. One proton, none of the electrons are there anymore because it has to be positively charged. Because H+ is pretty much just a proton all by itself, people very often refer to H+ in a more informal way. They call H+ a proton. So very often in biology and in medicine, people will say that hydrogen ions, a positively charged hydrogen ion, they might informally call it a proton. And in fact, this happens a fair amount. So another way of thinking about acids, I told you that our initial definition of an acid was some material that releases H+ ions. You can also think of it this way. You can let me back up there. You can also think of it as another definition of an acid is a material that releases protons when it's dissolved in water. And sometimes people will say that informally in biology and medicine. For those, and I will try to tie this into medicine at the moment, for those of you who, some of you might be familiar with this, some of you might have heard of medicines called proton pump inhibitors. Even if you haven't heard the term proton pump inhibitors or PPI, there are two very popular medicines. One is called Prilosec, one is called Nexium. These are both proton pump inhibitors. For those of you who don't know what Prilosec and Nexium are, they are used to treat heartburn and acid indigestion. And I'll explain how they work in a few slides, or in one slide maybe. Again, just to emphasize, these three little dots in a triangle here, this is a math symbol for therefore. So therefore, another definition of an acid is some material that releases protons when it is dissolved in water. And so basically proton is just a different way of saying H+ ion. So back to proton pump inhibitors. For those of you who maybe haven't taken anatomy and physiology, and I'm not even sure if they talk about this in A&P. However, this is basically what the inside of your stomach looks like. This is a cartoon version of the inside of your stomach. For those, when you when you digest food, the food goes from your esophagus into your stomach, and I imagine that many of you are aware that your stomach is acidic. So there's a fair amount of acid in your stomach. The question is, how does the acid get there? Well, by acid, what I mean is that your stomach actually has a lot of H+ ions, or a lot of protons, running around on the inside of your stomach. That's what makes your stomach acidic. How do those H+ ions, or how do those protons get there? It turns out that there are cells lining your stomach, all along the lining of your stomach. And these cells have little, very tiny molecular pumps. And these pumps actually pump H+ ions into the interior of your stomach. And so you can imagine these tiny, thousands or millions of these tiny molecular pumps actually throwing H+ ions into the middle of your stomach. And because they are throwing those H+ ions into your stomach becomes more acidic. However, sometimes these pumps can do their job too well. They can throw too many H+ ions into the inside of your stomach. Some of the excess acid, or H+, bubbles up into your esophagus. It irritates the lining of your esophagus, and it gives you heartburn. And so, in many cases, what you can take is a proton pump inhibitor, a medicine like Prilosec or like Nexium. What Prilosec and Nexium do is you eat the pill ends up in your stomach, the pill breaks apart, and the molecules in the pill actually travel to the pumps, and they jam the pumps, and they basically stop the pumps from throwing H plus ions into the interior of your stomach. Because of that, they are called proton pump inhibitors, because these pumps are pumping protons, and the Prilosec and Nexium molecules actually inhibit them. They shut those pumps down. And if you shut the pumps down for long enough, eventually the extra H plus ions will wash out and basically wash out through your system, and your heartburn will go away eventually. So that's how proton pump inhibitors work. There's another proton pump inhibitor that's on the market as well. You may or may not have heard of it. It's called Protonix. But if you have heard of it, or I guess now you have heard of it, you'll see where this name came from. I don't know how much they paid the person to come up with this name, but it's called Protonix because it nixes the protons. So there's a very clever name for a medicine whose molecules actually jam these pumps that sit in the lining of your stomach and throw H pluses into the interior of your stomach in order to acidify it. So that's the end of the biology lesson. Now I just want to summarize our introduction to acids. So as far as the punchlines are concerned, one definition of an acid is it's a material that releases H plus ions when it's dissolved in water. H plus ions are basically the same thing as a proton. And so sometimes, very often, people will refer to H plus ions as protons. And acids are used in our bodies, in our cells, pretty much any place you can think of. For different purposes. So we're done introducing acids. The next thing that I'm going to introduce are bases. So that will be the next section.